Now let's look at how efficient different transport options are today. What I've done is calculate the energy in megajoules you need to transport one person for 100 kilometers for different forms of energy. And here's what we get. Now by this metric, the worst form of transport using 600 megajoules to take one person, 1 kilometer, is ocean liners. Helicopters are almost as bad. Cars, somewhat better, but still pretty bad, about 250 megajoules per person per 100 kilometers. Airliners are better than cars, for reasons we'll talk about later. Bus, also better than car. That depends how many passengers are on the bus. An empty bus is worse than a car. Then we go to the better options below 100 megajoules per person per 100 kilometers, and a hybrid car is somewhat better, for reasons we'll go into. A suburban railway, much better. Electric car, better still. High-speed trains, similar. Walking, even better. And best of all are bikes and e-bikes. So you can see there's an absolutely amazing difference in the amount of energy you need to ride an e-bike over a given distance compared to ride on a cruise liner. Now, one caveat is a lot of these things depend on how many people there are in your form of transport. So the ocean liner, I've counted the passengers only, but there's also a lot of crew on these things. And you could certainly pack vastly more people onto a cruise liner if they were all packed in like economy class on an aircraft. During various wars, ocean liners were converted into troop carriers, and they'd get 3 or 4 times more people. If you pack a lot more people into it, they're actually much more efficient. It's the fact there's so much space given over to everybody that's why the efficiency is so low. Because in fact, ocean travel can be extremely efficient. That's why it's used as the cheapest way to transport bulk goods. It's just not so good for people because it's so slow. They need lots of space each. Likewise for the car, we've assumed 1.5 passengers, which is about the typical number in a car around Australia. Most only have one person, but a few have a family in. And again, if you're always carpooling and there are 5 people in your car, it's going to be much better than that. Airliners do well partially because they're usually quite full at the moment. For a bus, we've assumed that a typical bus in Australia is running with 9 passengers. If you could get them all crowded so they had 30 people on, they'd be much better. And so on and so forth. A lot of it depends on how busy these things are. People like to drive all by themselves. Most cars, you see them by the side of the road, have just one person in them. Another caveat is that we've not included the losses needed to produce the electricity. So the things indicated in green are driven by electricity, which is a good thing because you can fully decarbonise that. The energy efficiency is already pretty good, and then you can get the electricity from a renewable source and make them completely carbon free. So that's the good thing. The bad thing is that if these things are being powered by electricity that's coming from a coal-fired power plant, yes, your suburban railway might be very efficient, but the coal-fired power plant's only maybe 40 or 50% efficient. So in fact it's much worse than that because you have to allow for all the heat that was wasted in burning the coal to produce the electricity. And so on. This, for example, is why e-bikes come out better than normal bikes. They're actually equally efficient. It's just that a normal bike you're powered by a human, and humans are only about 25 or 30% efficient at turning food into moving your bike. But for an e-bike, you've got to think, where did the electricity come from? If the electricity came from a solar cell, that's only 25% efficient at converting sunlight into electricity, so that would make the e-bike look even worse. So these numbers are all pretty rubbery, but you get a rough sense of the enormous range in different efficiencies of different forms of transport.